Good morning. Today we are going to be learning about equations of lines, the different forms, and how to write the equations. The first one we are going to start with is your slope-intercept form. The equation that we will be using is y equals mx plus b. You've seen this last year in algebra as well. Things to remember: slope is standing for that letter m, and the y-intercept is b. The y-intercept being where it's going to cross the y-axis. So for number one, it's saying write the slope-intercept form of the equation. So what they're saying is, let's get it into this form of y equals mx plus b. So if we start with the equation that they gave us, 11x minus y equals a negative 51, it's saying I want to solve and I want to get y by itself. So the first thing we're going to do is subtract 11x from each side. Watch your negative signs. I still have a negative in front of the y, so that stays, which will equal, and now I'm going to write this so it's in that mx plus b form. I'm going to put negative 11x first, and then I have the negative 51. Okay, so we're close. The only difference here is our slope-intercept form has a positive y, and right now we have a negative y. So to make that positive, we're going to divide everything through by a negative 1. And we have to remember, when you divide negative by negative, it will equal a positive. So negative y divided by negative 1, we get a positive y. Negative 11x divided by negative 1, we get positive 11x. And then negative 51 divided by negative 1, we get positive 51. So right now, that's your slope-intercept form of the equation. We can say your slope for that equation is 11, and we can say your y-intercept is 51. Now another equation that we are going to get will be your point-slope form. So with your point-slope form, we have a different formula. So the formula we have is y minus y1 equals m times x minus, x1. So things we need to know. Again, m is always standing for your slope. And we're going to have a point. They're going to give us a coordinate. So that coordinate in that equation is going in for x1, y1. So we see down here on this example, we're going to write, and notice key things here, the point-slope form of the equation of the line, and it's telling us through this point. So when I'm looking at this point, I see 2 becomes my x1 of the equation, and 5 becomes my y1. And it says with the given slope of m equals 9 over 2. Okay, so the more you write the equation, the easier it'll be to remember it. So I'm going to start this off writing that formula down. So y minus y1 equals m times parentheses x minus x1. And now we're just going to plug it in. So y is going to stay y. y1 is our point. We have our point is 5. In place of m is your slope. Our slope is 9/2. And then we have x, stays x, minus x1, which is coming from our point, and that's 2. So we could stop here, because that's what the equation or the question is asking us to do. It's saying we want to write the point-slope form of the equation. This is our point-slope form, and at this point, we would be done. At times, questions will say, write it in slope-intercept form, which is what we did up above. But you're not given the intercept. So what do? Well, start writing it as point-slope form, but now we're going to transfer it into slope-intercept form. So very first thing we would do algebraically is distribute that 9/2 through. Okay, so nothing happens on the left-hand side. We still have y minus 5. Distributing 9/2 through, you have 9/2 x. Then 9/2 times a negative 2, so we get a negative. And once we distribute through, and remember you have a fraction button on your calculator to help you out if you need, This would simplify down to 9. Now we still want slope-intercept form, which means we got to get y by itself. So at this point, we add 5 to each side, and now your final answer becomes y equals 9/2 x minus 4. And now again, did you have to do this for this problem? No. This is just a, well, what if they said get it into slope-intercept form? Okay, so take it one step further. Okay, so sometimes they're going to ask you to write an example of a parallel line. So in our last unit, we learned about parallel lines. And we know that parallel lines, they will have the same slope, and that's huge. They have the same slope. So in this next example, we have to write the point slope form, so that's telling us how to stop. The equation of the line that passes through this point, so now again I see, oh, I have a coordinate. That makes me think that's x1, y1, and is parallel to this equation. Well, if it's parallel, that's telling me I need the same slope. So I'm going to go to this equation and say, okay, find your slope. Slope is always located in front of the x. This is telling me my slope here is 2. So my parallel slope also has to be 2. They have to have the same slopes. So now I have a slope and I have a point, and that makes me think point slope form, especially because that's my end result is point slope form. So I'm going to start with that formula again. Write it down. The more you write it, faster it'll be to memorize it. So we are going to plug things in. So I have y minus my y1, which is 1, equals my slope. Now, since it's parallel, we said same slope, so slope of 2. And then times x minus our x1. Well, notice our x1 is a -2. So when we have minus a negative, that's going to become plus a positive. Let me stop right here. That's your point slope form. It's parallel because it has the same slope. If we look at perpendicular lines, now perpendicular lines, we want to think, well, they have what's called negative reciprocal slopes. Okay, so that's a fancy way to say basically, you find your slope and you want to think flip and negate. Okay, so again, writing the point slope form. So that's telling me the formula that I'm using to begin with of an equation of a line that's passing through this point. So again, here's my x1 and my y1, and is perpendicular. Okay, so now I look at this equation and I say, okay, here's my equation. The slope of this equation we have to identify first. That's 3/10. And now it's saying perpendicular. So we know perpendicular lines have negative reciprocal slopes. So I want to take my slope, I want to flip it. So if we flip 3/10, I get 10/3, and I need to negate it. So I want to think what's the opposite of, in this case, positive. So the opposite of positive is negative. So this is the slope that we're using. And we have our point over here, that's our given point. So we're going to start again with your point slope form. Y minus y1 equals m times x minus x1. And we're going to plug it in. So we have y minus our y1. So now again, I have minus a negative, so that gives us plus a positive 5 equals our slope. We said it was perpendicular, have to use our flipped and negated slope, so that's a negative 10/3. Then we have x minus our x1, which is 3. Final answer, it's in point slope form. We have our flipped and negated slope, and we plugged in our point. Okay, last two things we're going to take a look at is horizontal and vertical lines. Anytime we're dealing with a horizontal line, it's always parallel to the x-axis. And if I were to find the slope of the x-axis, I could take any 2 points on the x-axis, calculate it. Your slope of the x-axis is always going to equal 0. So since it's parallel to the x-axis, that means any horizontal line will always have a slope of 0. always, always. So now we're going to write the equation of a line that passes through this point. Okay, so there's x1, y1. And it's parallel to the x-axis, so if I'm looking at this, I'm saying, okay, well, slope has to equal 0. I have a point, I have a slope, so I'm going to use my point-slope form. And we're going to plug it in. So I have y minus our point, which is 2, equals our slope, 0, and then x minus x1, which is 4. So something to keep in mind over here, since we have 0, okay, well, 0 times anything is always 0. So we're not going to leave it like this. We're going to simplify it and say, well, y minus 2 equals 0. And in fact, we're going to take it one step further to solve for y. And if I were to solve for y, I add 2 on each side, and I'm going to get the equation y equals 2. So what you're going to notice here is not only are all horizontal lines going to have a slope of 0, but all horizontal lines will always be in the form of y equaling a number. And that number is always going to be from that coordinate that it passes through. So vertical lines are similar, but vertical lines in this time will always be parallel to the y-axis. So again, you could take 2 points on the y-axis, calculate the slope, and what you're going to notice is the slope is always undefined. Any vertical line will always have a slope that's undefined. Okay, so if it's always undefined, well, let's think back to how we did our horizontal lines. They were always in the form of y equals a value. Well, your vertical lines will always be in the form of x equals some number. And that number, again, comes through the point it's passing through. Okay, so we're going to write the equation of a line that passes through the point and is parallel to the y-axis. Alrighty, so here's our equation. X equals 4. Done. Don't have to do anything else. It's an undefined slope. These are the only equations of lines that we will be dealing with that will be in the form of x equals a value. Every other equation of a line that you have will always be in the form of y equals a value. Hope you found this helpful.